Let's say you've got this function. It works perfectly, but you need to add a new feature to it. Maybe some caching to speed it up. But you really don't want to go in and rewrite the whole thing. Well, what if I told you there's an elegant way to do just that? Today, we're going to unlock one of JavaScript's most powerful patterns for enhancing functions without ever touching their original code: decorators. So here's how we're going to break this down. We're going to start with a really common problem: a slow function. We'll build a simple decorator to fix it, but then, oh yeah, we're going to hit a classic JavaScript roadblock: the mystery of the this keyword. From there, we'll discover the breakthroughs that solve it, leading us all the way to some powerful pro-level patterns that you can actually use in your day-to-day work. All right, let's dive right in with section 1, the problem. The challenge is simple but tricky. How do we make a function faster if we're not allowed to change its source code? Okay, so picture this. You've got a function that's doing some really heavy lifting, some intense calculations, and you find yourself calling it over and over again with the exact same input. That's just a huge waste of processing power, right? The big question is, how in the world do we optimize this without rewriting the function from scratch? And the answer, my friends, is a beautiful pattern called a decorator. The best way to think about it is like a wrapper. It's a special function that takes your function as an input, wraps it with some new behavior, in our case caching, and then hands you back a brand new souped up version. The original function, totally untouched. Now, you might think this sounds super complicated, but the logic is actually pretty straightforward. We'll build a decorator function that has its own little cache inside. This decorator then returns a new function. When you call this new function, it first checks, hey, have I seen this input before? If the answer is yes, it just grabs the result from the cache instantly. If not, no problem. It runs the original slow function, saves the result in the cache for next time, and then returns it. Simple as that. Okay, so we're feeling pretty good about our solution, right? It's clean, it's clever, but of course, it's not always that easy. Our elegant little decorator is about to run headfirst into one of the most infamous snags in all of JavaScript: the mystery of the lost this. And this is where we hit a brick wall. Look at this. When our slow function is just a method on an object, like worker.slow, everything's fine. But the moment we wrap it in our decorator, bam, it totally breaks. We get that classic dreaded error: cannot read property of undefined. So what just happened? The whole problem boils down to this one line inside our wrapper: let result equals funcx. When we call the function like this as a standalone call, it loses its connection to the original worker object. It loses its context. So when the original function's code tries to use something like this dot some method, this is now undefined. The function basically forgot where it came from, and everything crashes. But okay, don't panic, this is a super common problem, and thankfully, JavaScript has a powerful built-in tool designed for this exact scenario. And honestly, this is the breakthrough moment where decorators go from a neat trick to a seriously powerful tool. Let me introduce you to your new best friend, .call. It's a method that exists on every single function in JavaScript. It does exactly what it sounds like. It calls the function. But here's the magic. The very first argument you pass to .call is what you want the this keyword to be inside that function. You get to explicitly say, hey function, I need you to run, and by the way, this is your context. And just look at how clean that fix is. It's one little word inside our wrapper. Instead of just funcx, we now have func.call this x. The this inside the wrapper is the correct worker object, and we just forward it along to the original function. The context is restored, the link is reestablished, and just like that, our decorator now works perfectly with object methods. Alright, so we've conquered the this beast. We're feeling unstoppable, but our decorator still has a weakness. What happens if our function takes more than one argument? It's time to upgrade our decorator and make it truly universal. Think about it. Right now, our cache key is just based on that single argument x. That's not going to fly for a function like slow, min, max. How do we create a unique key for the combination of min and max? And on top of that, how do we make sure we pass all of those arguments along to the original function? So we've really got two challenges to solve here. First, the cache key. The solution is actually pretty straightforward. We can just create a simple hash function that joins all the arguments together into a single string. So if the input is 3, 5, our key becomes 3, 5. Easy enough. For the second challenge, passing all the arguments along, modern JavaScript gives us the spread syntax, which is just perfect for this. We can use func.callThis.arguments to pass the context and then all the arguments, no matter how many there are. Okay, now we're getting into some really pro-level stuff. This technique of passing the context and all the arguments from one function to another has a name. It's called call forwarding. And it turns out there's another tool in our toolbox that's even better for this job. Say hello to apply. It's like the twin sibling of call. It also lets you set the this context as the first argument, but here's the key difference. Instead of passing the rest of the arguments one by one, you pass them all at once, bundled up in an array or an array-like object. It's practically tailor-made for call forwarding. Let's just break this down super simply. You use .call when you have your arguments sitting around as separate variables, arg1, arg2, arg3. But when you have all of your arguments already packed together into something that looks and feels like an array, like the special arguments object, that's when .apply really shines. They both get you to the same place, just with a slightly different flavor. Alright, I'm going to save you a few hours of feature debugging with this next pro tip. It's a classic JavaScript gotcha. You might think, okay, to create my cache key, I'll just call .join on the arguments object. Makes sense, right? But it'll fail every time. Why? Because arguments is a liar. It looks like an array, it acts like an array, but it is not a real array, so it doesn't have any of the built-in array methods like .join. So how do we get around this? We use this awesome, elegant little trick called method borrowing. It's exactly what it sounds like. We're going to literally borrow the .join method from a real array and then use .call to force it to run on our arguments object. And here it is in all its glory. Join.call arguments. Isn't that cool? We're creating a temporary empty array just so we can access its join method. And then we're immediately using .call to tell that method, hey, I know you're used to working with real arrays, but today I need you to run using the arguments object as your this. It's a super concise and powerful method. All right, let's just take a step back and appreciate how far we've come. We started with a simple broken decorator, and we've built it up into this robust, context-aware, multi-argument handling machine. Now for the fun part. Where do we actually see these ideas being used in the real world? You've probably heard of these two heavy hitters, debounce and throttle. They are decorator patterns, and they are everywhere. Debounce is perfect for something like a search bar. It waits for you to stop typing for a moment, and then it fires off the search request just once. Throttle, on the other hand, is for limiting how often an event can fire. Imagine tracking the mouse moving across the screen. You don't need to run a function 1,000 times a second, maybe just once every 100 milliseconds. Both of these are built on the exact same principles of wrappers and call forwarding we just covered. So what are the big takeaways here? First, decorators are like reusable power-ups for your functions. They let you add features like caching or logging without cluttering up your core business logic, which is huge for keeping code clean. And the secret sauce that makes all the advanced stuff work, it's .call and .apply. They give you total control over context and arguments, which unlocks these incredibly powerful pro-level patterns like call forwarding and method borrowing. And that leaves me with one final question for you to think about. Take a look at the code you're working on right now. I'll bet you have some logic that's copied and pasted in a few different places. Maybe it's for logging. Maybe it's for checking user permissions. Maybe it's for timing how long something takes. That repetitive logic, that could be your next decorator. Thanks for tuning in.